of x is second derivatives. So what is the second derivatives? Second derivatives, if we differentiate any expression or any term two times, then that is called the second derivative. So we are going to discuss today that three questions we planned here. So question one, this, then another one, if function of x is given, then how to find out the x if second derivative value is given 0. And the last question we're going to discuss here, the third one, it's another function f(x) equals to something, how to find out the value of p by using the second derivatives. So second derivative actually second time differentiation. Let me get started from question number 1. It is written here in question 1a, right, that simple things. So we need to consider as a y equals to, it is given 12x square plus 3x plus 8. So first derivative means first time differentiation, dy by dx. We got from here 12 to the 24x, then plus 3. If you want to see the basic rule of differentiation, click on the I button and see the basic differentiation on the top right side. You will get how to do the basic differentiation. So second derivative, we need to write dy by dx of that expression, dy by dx. So this one, actually shortly we are writing d square y by dx square in the expression. It means that the term we have from the first derivative, we need to differentiate it again. So 24x plus 3, it gives us 24. So this is our answer for the first question A. Let's go for this question number B. I'm going to write here B. Let me write first the expression y. It is written here 16x plus 6, then plus 3x to the power minus 1. So as a first derivative, we can write dy by dx, which is 16. Then from 6 we got 0. Second one is 0, and third one minus 3 x to the power minus 2. Now let's go for the second derivative, d square y by dx square. So 16 is a constant, gives 0. So only the term we are going to differentiate that term. It gives us 3 to the 6, positive 6, x to the power minus 3. So we can write it as a 6 divided by x cube. So this is our answer of the second derivative. So why we are doing the second derivative? Because we have some application for doing the second derivative, especially for finding the maximum value, minimum value, stationary point. Then some other purpose we are going to use this. So let's go for this question C. We can write it 9x to the power half, and another term minus 3x to the power minus 2. That is the value of y given. So if we do the first derivative, dy by dx, we needed to write. It gives us 9 into half, and from power we are going to subtract 1, so half minus 1, then minus 3 to the 6 plus 6 x to the power minus 3. So for simplification, you can write one more line, 9 by 2 x to the power half minus 1, which is minus half, then plus 6 x to the power minus 3. Then for second derivative means differentiation of that expression dy by dx another time. This is called the second derivative, d square y by dx square. We are writing like this. So which is 9 by 2 into minus half, then x to the power minus half minus 1. And another part we can write directly, 6 3 is a minus 18 x to the power minus 4. So from there we can write our expression like minus 9 over 4, then x to the power minus 3 by 2, then minus 18 x to the power minus 4. So simply we can leave our answer here, or we also can write as a, uh, a normal form. So let's go for the last question D. We can do it very easily by using the UV rule rather than breaking down it. So we know y equals to you needed to see the product rule. There is a video for the product rule on the I button. Please click the I button, then you will get it. So which is 5x plus 4, then 3x minus 2. which you can denote the first one as a u, second one as a v. So let me do first separately, du by dx, which gives us 5, and dv by dx, which gives us 3. So now our first derivative dy by dx we can write directly, which is u dv by dx. So we need to multiply this two term, so you can write it 3 into 5x plus 4, and another term plus in the middle plus v du by dx. So we needed to multiply this two term again, so which is plus 5 into 3x minus 2. So this is our first derivative. So for the second derivative, just you can write it d square y. Without breaking down it, we can do the second derivative. See, in the first case 3 is a constant, so let me write here 3 first, and inside the bracket if we differentiate we got only the 5, done. And from the second part it is written here 5 into inside the bracket if we differentiate we got 3 again. So 3 5 is the 15 plus 15, we can write our answer as a 30. So we need to write d square y by dx square. So this is the second derivative. Second time differentiation is called the second derivative, and there is a lot of uses of the second derivative, so we'll learn it the next video. So just we are going to focus on only our how it works. Fx is written there, and x where it's written actually incorrect, we needed to write here double prime x equals to 0. How to find out the x? So first single prime x, this is called the first derivative. So just we needed to apply here the chain rule here, because something to the power 3 given. So if you don't know about the chain rule, please on the top right side button click the I button to get that video. So then you can write here the first derivative as a power, we are going to differentiate 3 into twice x minus 3. From the power we are going to subtract 1. Then if we differentiate the inside, we got 2 from here, because inside 2x minus 3 is given there. So our final part from here 6, then on the bracket 2x minus 3 to the power square is remaining. So let's, because it is written here f double prime x, so f double prime x means second time if we differentiate the first expression, first differentiate part, then we get the second derivative or double prime fx. So it gives us same way, chain rule only to apply 6 to the 12, then inside the bracket it is written here twice x minus 3. From power we needed to subtract 1, which gives us 1, and inside the bracket if we differentiate we got another 2. So our final expression is 2 into 12 is 24, and on the bracket you can write twice x minus 3. So this is the expression where you can write double prime x is this one. So according to the question, we needed to write here 24 bracket twice x minus 3, let we consider equals to 0. From here you can get our value of x, so we can write here 2x minus 3 equals to 0 as well, and x from here we got 3 by 2, or we also can write 1.5. This is our answer of this question. Second derivative value is given, we are going to find out the value of x. So the last question is by using the second derivative, it is written here f of x is, that is the expression. So the question is finding the value of p from here. So at the point x equals to 2, we are going to use that expression. So again you needed to differentiate it 2 times. So first differentiation or first derivative we got from here 3p x square, because p is a constant here. Then next we got from here 3 to the minus 6px, from x we are subtracting 1, then plus twice x, then minus 0, because 4 gives us 0. Now let's go for the second derivative. Second derivative, it is gives us 3 to the 6 px, because from power we are going to subtract 1, and x 6p is a constant, then we'll get from here minus 6p, x gives us 1 only, and plus 2x if we differentiate we got from here 2 only, and 0 becomes 2. So this is the value of our second derivative. Now the question is, they wrote here f double prime x, second derivative is value given minus 1. From here I wrote this one, and in this expression from the left side part we can write it, say this one. So one more thing we can do from here, say if double prime 2 x value is to given, let me put it here in that expression. We can simplify more from here, which is 6p into 2 minus p plus 2. So it gives us 6 to the 12 minus p is, which is 11p plus 2. Then let me use this expression here better, which you can write here 11p plus 2 equals to minus here 1. So it's so easy right now to get our value of p. So p 11p you can write here minus 1 minus 2, which gives us minus 3. So p equals to minus 3 by 11. This is our answer of this question. So this is our actually topics to discuss in this video for learning the second derivatives. Likewise, before we prepared one worksheet for you to for practice, and it already has been uploaded in the Google description below. So you're welcome to download it for your practice. In next video, we are going to discuss the chapter which is stationary point.